Hello and welcome to this ARA webinar with the staff from CPDA, the Council of Producers and Distributors of Agrochemicals, titled Adjuvant Advantage for the Sales Agronomist. My name is Hunter Carpenter, Senior Director of Public Policy with the Agricultural Retailers Association, and I'll introduce our webinar speakers in just a bit. But first, I'll go over a few things so you know what to expect. We recognize it's been an extra challenging season for you. So first off, we thank you for taking the time today to learn something new with us. Webinars are an important part of the ARA professional development pathway and provide a great opportunity for ARA member companies to help educate their employees. Questions will be addressed at the end of the presentation, but you can type them into the chat panel or Q&A section at any time. Today's webinar will be recorded, and the recording will be added to the member-only ARA dashboard section of the website. As a reminder, you can log into the member-only ARA dashboard to access past webinar recordings on sustainability services, data trends and conservation, and many more. If you do not have an ARA login, you can email Andrea Mowers at Andrea, A-N-D-R-E-A, at aradc.org to set one up. With that out of the way, I'm excited to introduce our two speakers, Johnny Roberts, Director of Education, Adjuvant Chemistry at CPDA, and Joe Janalski, Director of Education, Adjuvant Development at CPDA. Johnny has 45 years of experience in the development and technical support of pesticide, fertilizer, and adjuvant formulation. 44 of those years were spent with Helena Agri Enterprises. Johnny is also the co-inventor of 15 U.S. patents related to pesticide, adjuvant, or nutritional formulations. Joe has over 40 years of experience in the development of adjuvants and spray application technology. 35 of those years were with the legacy Winfield United companies. Joe also holds 41 U.S. and international patents on the composition of new agricultural adjuvants, wind tunnel design, and application technology. He's the author of numerous scientific publications on these topics. And with that, I'll turn it over to y'all.
Okay. Thank you, Hunter. Next slide, please. Boy, welcome to everybody that's joined us on this webinar today. Before we get started, I want to send a big thanks out to the folks on our advisory working group. They represent the majority of these products that are manufactured and sold in the U.S., and their input was invaluable in putting this presentation together. Next slide, please. A little bit about the agenda. The goal today is to talk more about the why of adjuvants than how they work. We see other webinars in the future where we get into the how, but today we're going to focus on the why. And what do they do? Why don't we use them? What is an adjuvant? How do we select them? A little bit on adjuvant mathematics, which does not involve calculus, so no problem there. We'll be discussing drift and deposition agents, and then also the advantage of CPDA certified adjuvants. Next slide, please. First, a little bit about definitions. The main thing to understand under adjuvants are not pesticides. I mean, the purpose of these products is to enhance efficacy or reduce application problems. When Dr. Peter Halloway of Cambridge University was asked many years ago, what is the best adjuvant for a herbicide application? His response was that different adjuvants do different things in different applications. And I think you'll agree with us after the presentation today, that's still very much true. Next slide, please. First, these products are growing. That was not supposed to happen based on some early prediction, but here we are. There's some reasons for that. Our use of water-based suspension concentrates is increasing. We've had a trend toward lower spray application volumes for a lot of different reasons. As we lose our spray application volumes, our coverage goes down, so the need for more of it. As we've seen in the last 4 or 5 years, there's been a much bigger need for drift and volatility reduction as we got into these over-the-top crop applications of dicamba. There's been a big change in the active ingredients. You know, if you compare the active ingredients today to the ones that we had in the late 70s, they're much more fragile. They are designed to do their job and disappear. So that is a much different scenario compared to the ones that we used to have. As we get into these pest resistance issues, it becomes that much more important to get maximum performance out of them. To keep from having escapes and continuing that resistance problem. But the bottom line is, in the shift that we've seen in the change, we've gone from just 3 pesticide labels recommending an adjuvant to more than 1,000 today in basically a 40-year period of time. So a big change, and this continues to be the case with their growth. Next slide, please. First, and this is a question that you inevitably run into with growers and applicators. You know, why don't the manufacturers just build these materials in? It's an extra step. It's a lot of confusion of having to add them tank side. Why don't they just build them in? And that's a good question. And in many cases, manufacturers are actually able to build them in. But the reason they have not completely replaced adjuvants is that we have situations where there's just not enough room in the formulation. The desirable goal of having lower pesticide product rates per acre results in lower use of that adjuvant per acre. The classic example of that is the transition of glyphosate formulations from 3-pound acid equivalent to 5-pound. That's a 40% reduction in the product per acre, but that's a 40% reduction in the in-can adjuvant that it was included. So we've got a situation that is just essentially created one where we just don't have enough room to build them into the formulations. Next slide, please. There is a large grower impact that adjuvants have that a lot of you will not recognize or not aware of. We did an exercise with a working group of trying to assess just what happens when you don't include the required adjuvant. And we came up with a range of 30 to 90% reduction in performance. Some of them are quite dramatic. Selecting the wrong type of adjuvant can result in a 5 to 50% reduction in performance, along with increased risk of crop injury. And there's even a measurable gap when you select a sort of just get by adjuvant versus a premium one that can amount to 5 to 25% as a performance gap. Next slide, please. You can put a dollar value on this, and we did some exercises with different products, and we found that you could actually show a $12 to $36 per acre loss from leaving the adjuvant out, based on the yield loss and resprays and so on. Using the incorrect one can drop it to as much as $2 to $20 per acre loss. And then you can measure another loss due to the selection of using a less than premium one over just the ones to get by. Next slide, please. So the first consideration, and this is where we get into the selection issue, and always a lot of questions around this. So we're going to go over what are the considerations that make us pick the right adjuvant and what direction we take. And what you'll find then is the vast majority of the labels that recommend or require an adjuvant, it's either a non-ionic surfactant, a crop oil concentrate, or a methylated seed oil. And another component that is getting featured more and more on labels is ammonium sulfate, or AMS. And it's these labels that are our first stop, our first direction. And failure to follow them, leave the adjuvant out, you can either violate the product's warranty or the pesticide label itself when you're dealing with over-the-top applications of dicamba. Failure to include the correct one can oftentimes result in compatibility issues, efficacy loss, and crop injury. Next slide, please. So there are types of adjuvant label recommendations, and that's what we want to go over here as being our first step. The first is where the adjuvant is just required. You don't have an option. The classic example we have today are the dicamba over-the-top applications. you have a requirement to include drift reduction adjuvants, volatility reduction adjuvants. So that's pretty straightforward. Then you have another group of products where the adjuvants are just suggested. They're not required, but they'll suggest the use of one if growing conditions are not favorable. If there's the conditions for weed control not favorable, they'll suggest one. Then you have another group of labels where there's not many of them, but you're prohibited from adding any adjuvants. And typically that's based on a crop injury concern, but there are a few of those out there. And then you have the situation, and this is where you generate the most questions, where they're just void. They make no recommendation, suggestion, or prohibition. You'll find that most of your fungicide and insecticide labels are that way. And the real reason for that is that most of the research and experience over the years has been done with herbicides, so they tend to be further along with their adjuvant recommendations. So we get a lot of situations where the adjuvant need is implied. Next slide, please. And what we've done here, we have taken actual verbiage off of existing pesticide labels that are actually implying that you add an adjuvant through their descriptions here. For example, you'll see terms like thorough spray coverage should be uniform and complete. Use appropriate drift precautions. Thorough coverage is important. Avoid off-target drift. These are all recommendations for adjuvant products because they would have a role in meeting each one of those. When they talk about verifying compatibility, adding a compatibility agent, etc., all those are leading up to using spray adjuvants. When they say that it must be uniform and coverage is complete, again, implied language that recommends the use of spray adjuvants. Next slide, please. You can divide this big group of adjuvant products, and it can be very complex, but you can divide them into two big groups. There are the enhancers, products that enhance the pesticide's activity, and then there are utilities, products that just simply address some application issue. The examples of enhancers are the things like nononic surfactants, oil concentrates, MSO, seed oils, deposition aids, ammonium sulfate. These materials can actually enhance the activity of that pesticide. When you get over into utilities, they may not have any direct impact on the pesticide's efficacy, but they fix things like foam. They address water conditioning issues, water quality issues, reduce vapor, and so on. So those are your big two groups to start with. Next slide, please. The next consideration that runs into a situation where you're trying to recommend or pick the correct spray adjuvant, you can divide most pesticides into things that are contact in their activity and others that are systemic. Some have a little bit of both, but those two big categories are the main ones. And that has an impact on what adjuvant works the best. When it's a contact, you tend to worry about wash-off issues more. You have more issues related to not having coverage, and you have less need to worry about absorption enhancement, and they tend to have less properties of being oil soluble when you are being more oil soluble rather. When you get to systemics, it can be totally different. Evaporation is a big issue. If you get evaporation, you get less uptake. The need for absorption enhancement becomes much greater. The impact of that plant surface has more of an issue on that material working. The impact of water quality can come into play more with systemic materials as well. Next slide, please. So to kind of summarize, oils and surfactants as a group increase the performance of active ingredients by either increasing their absorption, their coverage, their deposition, or retention. So that's the key point. They're not pesticides themselves. They simply make the materials work by enhancing their absorption, coverage, deposition, or retention. Next slide, please. You can break them down broadly into surfactants and oils that we've been talking about. The surfactants increase the wetting, spreading, reduce the spray droplet bounce, tend to improve coverage, while oils tend to enhance absorption and uptake, reduce evaporation, enhance deposition, and add resistance to wash off. And you tend to find most of your oil-based adjuvants, a lot of them in aerial applications for this reason, because they do contribute much in those categories. Next slide, please. So we get into use rates, and this becomes an important topic. Okay, with surfactants, typically their recommendations per label are 6 ounces to 2 quarts per 100 gallons of water. That's 0.05 to 0.5% by volume. And we tend to see them used at lower rates when the spray application volumes are higher. The thing to keep in mind about surfactants is they treat the water, not the acre. With oils, the typical use rates, and this is both with CLCs and MSOs, runs from 2 to 4 quarts per 100, which equates to about 0.5 to 1% by volume. With aerial rates, you tend to get a 1 to 6 ounce per acre use rate. And the thing to keep in mind about oils is now you have something that impacts both the water and the plant's surface. And so that's a big difference with just the surfactants. Now we're talking about an input that has an impact on the plant surface as well. Next slide, please. And when we get into the oils, a key point with them is that they don't mix with water. Okay, and we have a saying in formulation development where gravity always wins. The oils that we're dealing with, they're all lighter than water. They're going to float to the top. So we're always dealing and fighting this situation when we're making spray mixes. Next slide, please. So these oil products utilize a special type of surfactant that's called an emulsifier. And what these emulsifiers are able to do is disperse that droplet of oil into such small droplets that they float instead of sink to the bottom. And what you get in return is a very uniform mixture of oil and water. Next slide, please. And you can see in this picture here, when we mix oil and water with an emulsifier, it rapidly rises to the top because gravity wins. But when we have an oil with an emulsifier, we get this nice, uniform, consistent, milky looking spray mix. That white color results from having droplets of oil so fine, so small that they have no other choice but to float. They reflect that all the light that strikes them, therefore they look white. So this is an important issue of oil-based product because having consistency and uniformity in that mixture is key to getting performance without crop injury. You could argue that under high agitation, my oil and water alone is uniformly mixed, but realize that keeping that mixture together is a big concern long after it gets out of the spray tank. So uniform emulsions are important. Next slide, please. This is where we get into the downside of using oil-based products, and that is the crop injury potential for this group of products can be greater. It's typically not the products themselves. If there is a crop injury issue related to the individual pesticide, by making them more efficient, they could aggravate that. As a general rule, as you move toward the aromatic solvents that are often found in emulsifiable concentrates, they tend to be the hottest. But if you have a methylated seed oil, paraffin oil, all the way down to the other straight seed oils, it tends to get lower. So you can keep that information in mind. If I'm dealing with an injury issue here, I know that the oil materials have the greatest potential for that, the surfactants the least. Next slide, please. What about fertilizers and spray adjuvants? And this is where we get into a relatively recent development back in the early 80s, where we're using fertilizers as spray adjuvants. The most common one is ammonium sulfate, but you also have UAN being used in particular with post-applied herbicides, and this practice is growing. AMS predominates at 8 to 12 pounds per 100 gallons of water, UAN typically at 1 quart per acre. And AMS has a dual role where it provides not only absorption enhancement, plus water conditioning. With UN, it's more absorption enhancement only. The way that an oil would typically do, you can use this particular fertilizer for the same thing. Some of that is related to evaporation reduction. Some of it's a lot more complex. The thing to keep in mind with fertilizers as spray adjuvants, they do not work the same way that surfactants and oils do. And then you'll also find a wide range in manufacturer recommendations. It's so wide and so diverse that it's difficult to say what it generally is. Typically with AMS, it's anywhere from 8 pounds to 17 pounds per 100 gallons of water. But you'll see a lot of variations based on the actual delivering a certain amount of ammonium nitrogen and the season that you're spraying in. Next slide, please. The thing to keep in mind about adjuvants, and this has always been the case, is that they have somewhat of an insurance role. You know, they're a tool that are protecting that grower's investment. If you look at the potential for lost product and those type of things, it's a very expensive policy for protecting them. The risk are reduced yields. The risk are having to do resprays, crop injury, and possible litigation expenses, but there's a big issue of the potential for lost time. Next slide, please. As I've often been reminded by the people that are actually selling and getting these people to the growers, the biggest thing that the grower is looking for from a standpoint of a benefit is saving time. It is one of the most valuable things that you can provide. If you can reduce my gallons per acre, you're saving me time in the logistics. If you can combine multiple components in one spray application, you're saving time. If you can stop this compatibility problem, you're saving time. That time is valuable in the standpoint of their operation and is key to making them be efficient. Next slide, please. So this is where we look at the role of adjuvants as problem solvers. It's rare the application that does not have some type of problem, often reoccurring ones, that we need to solve in the interest of saving time, in the interest of saving money for that applicator. There are mixing issues. There are wash-off issues that oftentimes result in resprays. There are times when it's just not active enough, like in a burn down situation, I've got to increase that activity. There are issues related to water quality being poor. There are issues related to, I've got to get more of this deposited deeper through the canopy. And oftentimes it is, I just need to clean up afterwards. These are all problems where adjuvants have a role in correcting. Next slide, please. You can categorize adjuvants in terms of their problem-solving capabilities. With non-ionic surfactants, for example, if you have a spreading and wetting or just a spray balance issue, they're perfect for correcting that, for improving those particular deals. If I have a situation where I know I'm not getting all my deposition to that crop canopy, I know that I'm in a hot, dry condition here and I'm losing water out of my spray mix, oil-based adjuvants are your obvious choice to fix that. If I'm dealing with frequent rains and I've got a particular pesticide that's subject to wash off, then the sticker type adjuvants come into play. If I'm just trying to make that material hotter, more active, trying to get a more thorough burn down, then there are the activator type adjuvants that can be considered for that purpose. If I'm having issues with just compatibility and foaming, then your mini utility products can intervene in that. So the key point here is to keep these products in mind when the goal is to prevent problems or solve them. Next slide, please. This particular slide was put together by Dr. John Nalawai of North Dakota State University, where he tries to summarize how that you'll get different adjuvants acting differently depending on the situation you're in. If your spray conditions are adverse, and what I mean by that is poor water quality, hot, dry, those type of situations, your oils, fertilizers, methylated seed oils are going to be at the top of the choice. If you're in good spray conditions, early in the season, lots of moisture, surfactants are often good problem solvers. If I've got weed control issues that are just really getting on high, the weeds are too high, they're getting off label, we're getting into situations of drought where weed surfaces are getting tougher, then that's going to favor the oil, fertilizer, and methylated seed oils. And my crop injury goes up higher, but it is a consequence of looking at a tool for the higher control. Next slide, please. A little bit on adjuvant mathematics. And if you'll notice that with most adjuvants on the labels, they'll give you a percent by volume recommendation or percent by weight. With oil adjuvants, you'll see situations where they're often rated on per acre basis, but they also have per volume recommendations. Next slide, please. And this shows you the impact of spray application volume on the cost of using adjuvants. If you take your typical non-ionic surfactant, 1 quart per 100, that's a 0.25% by volume non-ionic surfactant. If I'm doing this in a 10 gallon per acre application rate, that's 3.2 ounces of the adjuvant per acre. If I go up to a 20 gallon per acre application rate, that jumps to a 6.4 ounce acre application. So for $32 per gallon adjuvant, that works out to about a quarter per ounce, which is equal to 80 cents per acre if I'm doing 10 gallons per acre, $1.60 per acre when I'm doing 20. And the problem with this, and this is a great way to look at the cost of these surfactant applications, but the danger you can get into is when you start cutting the adjuvant rate. Next slide, please. For example, if I'm in a situation where I have to go from 10 gallons per acre to 20 gallons per acre, driven by the label, and I've got a 0.25% by volume adjuvant, there's a tendency to drop that adjuvant rate to get it to the same cost per acre. And that is a undesirable situation from the herbicide performance. That recommendation was not based on having the use rate cut. And so it's often the source of non-performance issues or less than satisfactory issues. It can be particularly a problem with non-ionic surfactant combined with AMS, in that where someone has gone up to a higher spray volume and they try to cut that back to fit those economics. Next slide, please. When we get into oils, it becomes even a more significant issue. Typically with oils, okay, they have a rate per acre. And recently we've had academia remind us all that there is a certain minimum of crop oil concentrate and MSO that should be used per acre. What the problem has become is that a lot of labels have 1% by volume recommendations. Well, when that 1% by volume recommendation for a crop oil concentrate or MSO was 20 gallons per acre, then you got into the 1 pint to 2 pint per acre minimum that you're needing. So, if you don't make an adjustment, if you go to a lower spray volume, which is very common, and you don't make an adjustment for the oil adjuvant, you can wind up putting out less per acre. And on this whole subject, and it's something that becomes important, when growers assess costs, they do so on an application per acre. And so keeping that math straight, keep understanding what the actual cost is per acre based on the per volume used is important for just both performance and considerations of the cost. Next slide, please. One of the newer innovations in the adjuvant world, and what's interesting about what we call high surfactant oil concentrates, or HSOCs, this was an adjuvant that was actually developed by and came from adjuvant producers. And what they identified is that there's a gap here. You have labels that recommend either non-ionic surfactants or crop oils or MSOs. And there's a certain amount of confusion. When do I need both? Having the properties of both could be advantageous. And so this introduce a new category where we basically have a crop oil or MSO that is designed to go out on a per volume basis. The thing to keep in mind here is if you're dealing with an oil-loving herbicide, for example, clethodim, it's still important to keep your application rate of oil per acre where it's supposed to be. This keeps the cost per acre stable, but these are great tools for simplifying adjuvant choices, particularly when you have this indecision between a surfactant and an oil. Next slide, please. This is where we're going to pick up and talk about arguably an adjuvant that has a place in every pesticide application, and that's drift and deposition agents. And so with that, I'm going to turn things over to Joe.
Thank you, Johnny. I have a real passion for the drift and deposition agents through my career. And as I looked at, whenever I see a sprayer in the field and I see a fog of fine droplets coming behind it, it bothers me a great deal because I know they can do better. And Johnny covered a lot of these implied label inferences, and that's really where most of your ability to put a drift and deposition agent in a product come from. And so basically what you're trying to do, and in my opinion, they should be called deposition agents because that's what they truly are. And the goal here is to keep a higher percent of the spray on the intended plant. So as I said before, most drift control agents are deposition agents because they're reducing the fine particles that come out of the spray nozzle. A good deposition agent increases the spray coverage, so it increases the effectiveness of the herbicides, insecticides, and fungicides. And if you look at wind tunnel data, you can see there are a lot of products that do this, and they simply improve the performance because you're delivering 5, 10, 15, 20% more of the active onto the plant where it needs to be. And so by doing that, then you also reduce the off-target movement. Next slide, please. And this slide's been around a long time. Former company I used to work with put this together. This is an actual plot that we did long ago by simply adding the deposition agent. And this was with 20 gallons of water. And this was about an 8-foot tall corn plant. But you could see significant movement of the spray pattern with the simple addition of a low rate of a drift and deposition agent that you got coverage down. And I know at this full close to tassel, there are some restrictions on adjuvants, but you see this benefit greatly even on the corn applications that are going on that V5 to V7 stage, and certainly on the soybean plants. A deposition agent in that is going to pay for it every time. Next slide, please. And we jumped ahead a little bit, but I'll cover a little bit more on the deposition. One of the things we've seen, I think Johnny and I've seen through our whole career, is the big problem adjuvants has is when we get down to the retail level, we're often right at the retail level, we see objections to why are we spending this money on spray adjuvants. And one of the common objections, and Johnny covered a little bit earlier, but if they're needed, why didn't the manufacturer build them in? And why they try, there's basically insufficient room to put it in that product. And then when you start varying from a 10-gallon application to a 20, it just doesn't work for the manufacturer. Their goal is to provide you the largest amount of the AI of that herbicide, insecticide, fungicide they possibly can get. And that's why we have tank mix adjuvants. The other one is the pesticide label does not recommend them. And that's simply not true in many cases. As we saw, there's thousands of labels that do specifically say you have to put an adjuvant with it. But in other cases, you go back to that implied use that really indicates that you need them. And to get that improved coverage and deposition, you need to put that adjuvant system in there. Another one time, a lot of our manufacturers or sellers of adjuvants say, well, they'll give you quicker activity too. And while that's true, because you're getting more of the intended pesticide on the intended target, you often do see a quicker activity. But really, they aren't focused on the quicker activity. What that quicker activity means is you've improved the coverage and the deposition, especially in adverse conditions. And then the last one we get to is, well, they're just adding cost to my spray tank. And while that's true, when you compare the risk versus the reward, they're very minimal cost, and failure to improve them and sometimes violates the label. But in reality, it's $12 to $36 an acre that you can be throwing away of that product that you put in the spray tank. And that doesn't include if you had a respray or if you get yield loss from increased weeds in the field and such. Next slide, please. We'll pop back to that economics of using drift and deposition agents. And this is a made up slide saying on a fungicide application, if you're putting $30 an acre, and I know you can do it for less than that sometime, but still, they want you to use a finer spray tip for this, for smaller droplets. So you've got more fines inherently with it. So you're easily getting up to a 20% loss in deposition of droplets that either dry up before they hit or they simply blow away. So 20% of 30, even this South Dakota farm boy says that's $6 an acre right there. Virtually none of these drift and deposition agents are going to cost you $6. And it doesn't include the possibility of the yield increases, which you almost always get. You see a lot of good data around this. You got an advantage of $15 to $20 an acre by putting that deposition in the spray tank. It's easy to show in fungicides, but generally speaking, you're seeing the same thing with your herbicides. Next slide, please. As we said before, these are easy to demonstrate. I've seen people do it in large sprayers where they add the deposition agent as you're going on, and you can see the reduction in the fines as that deposition agent gets there. So again, an excellent cost benefit saving of 10 to 20% on herbicide. It helps you fight weed resistance. And you've all got access to good of them. There's a lot of good products out there, and you've got, I'm sure, products in your lineup that are ready to do this drift and deposition work for you. So our challenge to you is to let's try and get all the acres that we need to with drift and deposition agents in 2023. You're doing the grower a real service by putting that drift and deposition agent in the spray tank every time. Next slide. One other thing I'll hit on, approvals showing up on Enlist and Genie Extend and the other products. Many people take this as, oh, that's an endorsed adjuvant. That's a good adjuvant because it's on that list. In reality, it's not. They're really only evaluated for droplet size, and now on the Genie Extend also on volatility. It has nothing to do with how that adjuvant is labeled or how it works. It's just on the list because it didn't affect the droplet size. So don't take that list as an endorsement that, hey, this must be a good product because it passed the test. Not necessarily so. Next slide, please. So why are there thousands of adjuvants available? It's easy to get into the markets because there's very limited regulations around them. And so that's why you literally see thousands of adjuvants out there. So how do you kind of sort that out? As we look at these, only 2 states totally regulate adjuvants, and that's the state of Washington and the state of California. There are other states that do require some form of registration. But it's this many states where you don't need regulations does does create labels that aren't necessarily proper, and they don't always talk about the what's really in them or the functions or the quality of them. So that's why one of the key things on adjuvants is the training on the proper use of them, and knowing the products you're selling is extremely important to you and to the growers you're trying to serve. Next slide, please. The other time tradition of the adjuvant business is the argument about the difference between a 90-10 versus an 80-20 non-ionic surfactant. It goes back to one of the original ones, if not the original X77 adjuvant, came out by Ortho, I think almost before Johnny and I started, but maybe not quite. But 90% blend of non-ionic ethoxylates, free fatty acids, isopropyl alcohol with 10% water. That's where the 90% came. It had 10% water. All the rest were not necessarily surfactants. It became an unrecognized industry standard for the non-ionics. However, the 90-10 does not mean that it's got 90% non-ionic surfactant. There may be a few that do, but they are few and far between. So typically the surfactant levels are significantly less than 90% true surfactant. Somewhere along the way came apart the 80% non-ionic surfactants, which really doesn't explain anything either, because most of those truly do not have 80% non-ionic surfactant. It probably just means they've got 10% or 20% water in the system rather than 10. So there really is not a true difference between an 80-20 and a 90-10. You really need to look at who's providing these to you and talk to them about what's really in there and how much surfactant is in them to really understand the difference between an 80-20 and 90-10. The one thing I'll talk briefly about the CPDA certified adjuvants. At this time anyway, those products that are listed as a surfactant need to list the actual amount of true surfactant on that label. Next slide, please. So as we try to sort out all these differences, I alluded that there are thousands of adjuvants. The one attempt that CPDA has made to try and put a little saneness into this was the CPDA certified adjuvant program. Started almost 20 years ago. We did this to try and keep so many states from regulating adjuvants independently. And so we made the effort through CPDA to put some product integrity around CPDA certified adjuvants. What we really do ensure to growers that the product meets the claims that are indicated on the label. It ensures growers that the products meet EPA regulations. In other words, there's product chemistry and tox done on all of these, and that's really the big part of this is they are documented to have product chemistry and toxicological data done for them. Now we are working on redoing this to try and get more. Currently, we've got over 250 adjuvants on this certified list. We're working on revising it to get more in line with the regulatory pieces on it to get more more retailers and dealers to certify their system. One other thing I will mention, we're also, CPDA is working on the CPDA application enhancement program, which is designed to look at drift and deposition agents and show how much they do for you on an individual basis. So that's another program we'll be kicking off in the near future. Next slide, please. So consider using a CPDA certified adjuvant. You can look at our website. You see this. You'll see all the certified labels. Other good sources, the compendium of herbicide adjuvants, and I think many of you know about that out of Purdue University and Southern Illinois. They update that annually. At least it gives you a total list of all of them. And again, they don't have them all on there, but they're working hard to do that. Another great publication is Adjuvants and the Power of the Spray Droplet by the Purdue University. And the other thing we would recommend, ask for research data on adjuvants if you've got real questions on them, and consult with your distributor who all have adjuvant experts and help you make the right choice. Next slide, please. So again, wrapping it up, what does it all mean? See what the label says. Is there a specific adjuvant required? Then you really need to use it. The other thing to look at, what type of AI are you using? For contacts, you're generally using surfactants. You want to spread that out over the leaf surface better. And for the systemics, you got to get it in with an activator, typically oils, to drive the herbicide in through the leaf cuticle. And then look at what other problems you're trying to solve. Drift and deposition, almost always an issue to consider. Water quality is also something important to look at. And remember the difference between hard water and pH. Hard water is what really affects glyphosate and glufosinate, and then help improve through surfactants, help give you better compatibility. Next slide, please. With that, we've arrived to the questions. We've popped up the slide again for those that didn't catch that need CCA certification. There's the code back up there. And Hunter, we will have you see if we got some questions.
Great. Thanks, gentlemen, for a terrific presentation. We'll start with some questions that were posed ahead of time in the registration and then move on to the Q&A that were posted here. So one question was, I'm curious if there's an OMRI listed adjuvant list that exists with any of the participants. I believe this is an unmet need of the industry for both row crop and specialty customers.
Yes, I'll take that one. And indeed, there are. There, of course, they're specialized type adjuvants to be able to meet the use qualifications for an organic product. If you will check the OMRI product listing, you'll find a number of them that are available for use. And this is an area that recent work has shown there's some great benefits from using adjuvants with organic inputs.
The next question, how does water quality play a role with respect to the efficacy of adjuvants?
Water quality has a huge impact. I mean, especially again, we think a lot about, people think pH is water quality, and why extremes on pH can cause issues with some pesticides. I really look at water quality as typical how hard it's the water. And that's going to have an impact, especially, again, as I mentioned earlier, on glyphosate and glufosinate. If you've got really hard water, you need to utilize a water conditioner and the AMS in there. But yes, keeping an eye on the water quality. Both the pH and the hardness are two extreme things you need to look at, and adjuvants can help you with the extremes there.
Next question, is it possible low surface tension and low driftable effect in the same adjuvant?
Yes, those products exist. The thing that we recommend there is that data be provided to support that claim, because you can get the opposite, where too low a surface tension can cause more driftable fines. But yes, you can formulate, and there are products on the market that are able to reduce surface tension while reducing and preventing driftable fines.
Next question, what is the role of adjuvants in low volume applications?
Well, I think that's especially in low volume ones where you really need to get the deposition. Typically low volume applications, you're using a finer spray to get coverage, but at the same time, if you're driving it too fine, then those dry up or blow away, and so your deposition agents in the low volume applications is a critical thing to look at.
Next question, we have developed a low volume spray system that can handle viscous solutions, and I'm interested in becoming more informed on the general adjuvant scene to better develop a trial program with the spray system. No real question, but any comments there?
Take a shot at it.
Well, with a diverse range of products that are on the marketplace, you should find something to accommodate any viscosity. I mean, I'm not going out on a limb by saying that. There's quite a number of products in the marketplace that are able to reduce viscosity to make things more sprayable at the same time, not causing some negative related to compatibility or driftable fines.
And next question, do you think we're at risk of confusing that body of 55-plus-year-old farm operators that remember that industry direction with now a theme of let no weed survive, multiple MOAs, higher dose rates, complementary impact of adjuvants, et cetera, equals a greater overall weed control? In some sense, are we still too focused on synthetic weed control versus other methods?
The future for ag chem products is going to be doing more with less. And we're going to be able to do that with these new precision sprays, the new technologies that are coming. And, you know, I could argue that they have a great role in this new world of more with less. You know, when the issue is coverage, evaporation, all these things that we are talking about are actually going to be bigger issues when we get into these reduced application scenarios. For example, on the drone technologies, the driftable fine issue increases because of the low the coverage they're having to get out of just a quart of water per acre. So yes, these products do have a good fit in fitting this new world that we're evolving to, where we get essentially more with less.
I think it's a great opportunity for our young scientists to tackle this, but I agree with Johnny. I think the role of adjuvants will be even certainly as important, but maybe even more important in the future as we look at these new technologies.
Next question, can deposition aids in a non-ionic or crop oil adjuvant be used together to reduce drift and improve leaf coverage?
You want to do that one?
Yes,
Joe?
I think there are already products out there. Yes, there are products that do that, that have both.
Next question, I have grower who claims standard spray nozzles perform 20% better with glyphosate versus turbo T-jet nozzles. Any comments?
Well, I agree with him. Yeah.
Next question to see.
I think we better elaborate a little more on that. I do think that it's all about the coverage. I mean, those, and I assume he's talking the TTI nozzles, not the turbo T-jet, the TTI nozzles that do create such huge droplets. You have the opportunity to miss coverage with those, and I'm sure that's what he's saying is he's just got so many big droplets you're not getting coverage would be my best guess.
And that's as formulators, you know, that's becoming our challenge. I mean, how do we live in this new coarse spray environment and still control weeds and bugs, which is really the intention. And so we're getting better at that, but that's another one of those challenges for the young people that are coming behind us.
Next question, does CPDA certification require a 90% NIS?
No, the answer to that would be no. We just would require, the current standards would be, you would have to put on your label the percent of true surfactant in that mix. Yeah, you could technically certify one that has 20% surfactant, or you could certify one that has 90. You just have to disclose that on your label to be certified at the moment.
Does CPDA also approve the raw materials making the final adjuvants used by the farmers?
No, we have, you know, the CPDA that has no demands and no controls over that. You know, the finished product just has to meet the standards. And but there is no input into which raw materials that they use.
They would have to pass the toxicological tests, however, but not be approved. They'd have to pass the tox test.
Next question, can you address all-in-one products that have water conditioning, surfactant, and deposition aid in one container?
Yes, and those are quite popular. And the issue there is the use rates. You can come very close to doing all those functions with one product, but not when the use rate is cut down to a point where it's no different from other products. I mean, and inevitably, when you make multiple function products like that, you're diluting those functions to get them all working in that same jug. So the use rate becomes very important, and that it is able to provide all those functions at a realistic rate.
Next question, what percentage of applications made annually in the US do you estimate use an adjuvant? Given the clear benefits, why do you think this is the case?
Well, I think it's hard to tell the percent. I'll go first, Johnny, but I think it's hard to tell the percent. We know a lot of it get missed. I mean, we've got areas of the country where they're not using AMS. They think they don't need it because they look, hey, I got soft water, you don't need AMS. They don't recognize the fact that the AMS actually has other attributes to it rather than just the hard water aspects. And I don't know if we've got a good percent. Drift and deposition, we do know that we're lacking greatly in that. It's probably well under 20% of the tank mixes get a drift and deposition agent. I'm hoping it's in the well over 50 on the other ones, but it's less than it should be. Johnny, I don't know if you've got another opinion.
Yeah, it's part of it, and we're addressing it today. There's such a lack of training and information. I mean, and that problem seems to have gotten worse over the years, where it's just it's a group of products not discussed. They are sort of sneaky big in the sense that they can have a big impact on that pesticide's performance, but no one really knows or hears about them. You know, as long as we're spraying in water, you're going to have a need for spray adjuvants. I mean, it's that basic. And working on things like this, we'll be able to rectify that. You know, it's very easy to understand what a pesticide does. It kills a weed or a bug. Much more difficult to, or at least unfamiliar to growers about what these materials are supposed to do.
Next question, what's the impact of drone UAV application technology, ultra low volume application on adjuvant recommendations?
Well, I just completed a paper on that subject, and it's interesting. That's been well underway for 10 years now in Asia. They're making drone applications of pesticides. As you can imagine, you know, one of the big benefits of a drone application is getting your spray application volumes down. I mean, you're talking about as low as 1/2 to 2 quarts per acre getting an effect. The downside of that is directly opposite of what we're doing today with these coarse droplets. You get finer droplets. And so mitigating those droplet sizes, the adjuvants have a role. Most of the research is being concentrated on that. Imagine the evaporation problem of droplets that small applied over an acre. And so the oil materials have a fit there. There's experiments with fertilizers as the carriers. When we start talking about spray application volumes that low, we can start talking about custom carriers. And what you'll find that they all have in common is that they're using variations of the adjuvant technology that we're doing today.
Well, gentlemen, thank you again for your time today. That's about all the time we have. If you'd like to reach out to me directly, hunter@aradc.org. I'm happy to put out an introductory email to these gentlemen if you have more questions that we didn't get to. We want to thank you again, our speakers from CPDA, for delivering a great presentation. And thanks to all who participated today, despite your busy schedules. One more thing before you go, registration is open for the 2022 ARA Conference and Expo, held November 29th through December 1st in San Diego. We hope to see you there. Thanks, everyone.
Thank you, Hunter. Thank you, everybody.
Thanks, everyone.